Hello, grade 9s. This is our first unit here on polynomials. Just a little introduction. So we have to first of all know what the algebra tiles look like. So we can see here we have a positive x, a negative x, a positive x squared, a negative x squared, a positive 1, and a negative 1. So you can see that the positives are always dark, shaded in dark. The negatives are always white. Okay, so for example, one of the things you have to do is being able to represent a polynomial like 5x. So what does 5x look like? So if we had our tiles, 5x is like so. 1, 2, 3, 4, 5. Okay, 5x. Makes sense? Next one, negative 3x. What does that look like? So that looks like negative 1x, negative 2x, negative 3x. Negative 3x. Next, negative 4x squared. What does that look like? Well, we need a few other little ones here. So we need negative 1x squared, negative 2x squared, negative 3x squared, negative 4x squared. And there we go, negative 4x squared. So 5x, negative 3x, and negative 4x squared are all polynomials. They're made of one term, one part, one family, as I say. The name of these polynomials, these are called monomials. Mono and then meals. Monomials, they're one part polynomials. Okay? So moving on, this is a different kind of polynomial. It's got 2x, negative 4. So if I had to represent that, we have 2x, and then we have negative 4. There's negative 1, negative 2, negative 3, negative 4. 2x, negative 4. Here we have 5x squared minus 7x. So 5x squared. 1, 2, 3, 4, 5. And now we just need the, it looks like take away 7x, but think of it as negative 7x. So we have 1, 2, 3, 4, 5, 6, and 7. A little bit messy, but you get the point. 5x squared, negative 7x. Next one, negative 3x squared minus 12. So negative 3x squared, 1, 2, 3, and then negative 12. As you will notice, these are all white. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you can see right there we have negative 3x squared, negative 12 or minus 12. So 2x negative 4 or 2x minus 4, 5x squared minus 7x, and negative 3x squared minus 12. They're all polynomials with two parts or two terms. The name, what is the name given? Because there's two parts, we don't call them monomials, we call them binomials. All right. Finally, represent the polynomial negative 5x squared minus 7x plus 8. So we are going to go it's positive 5x squared. So 1, 2, 3, 4, 5. We need negative 6x. 1, 2, 3, 4, 5, negative 6. And then I need positive 8. So 1, 2, 3, 4, 5, 6, 7, and 8. A little bit messy, but as you can see, we have 5x squared, negative 6x, positive 8. Okay, I'm going to jump ahead because I think you kind of get the picture. So you can try representing that one, negative 3x squared plus x squared minus 14, and 4, negative 2x squared minus 3x. Try representing that. So all of these, they're all polynomials with three parts or three terms. What is the name given? If it has three parts, we don't call it mono, we don't call it bi, we call it trinomials. So those three have special names, mono, bi, and tri. After that, we don't really teach any other names than that, so you can just call it a polynomial. They're all polynomials, so it doesn't, if it has 1, 2, and 3, they have a special name. The other ones you can just call them poly. So name the polynomials. So we can tell here we have 3x plus 5. Next here, we have a negative x squared. We can say negative 1, but we don't prefer to put the 1. Negative x squared. Take away 3, but better say negative 3. Negative x squared, negative 3. Here we have 6, negative 6x's. That's a negative 2, and this is a positive 3x squared. So negative 6x squared minus 2 plus 3x squared is what it shows. So here's some terminology here. Anytime you have a number next to a letter, that number is called a coefficient. The letter itself is called a variable. The variable, if it doesn't have an exponent, there is an exponent, it's not shown. It's an exponent of 1. So here we have a binomial, right? Look at the black lettering. Negative 9x to the power of 4, 2x to the power of 3. So we have two coefficients, the number in front of the letter, negative 9, and the 2, which is negative. So you grab the negative as well. Those are the coefficients. The variables are the letter x, and the exponents are 4 and 3. Here we have a trinomial again. We have a coefficient 5 and negative 3. We have a variable y and x. This y has an exponent 1 not shown, this exponent of 2, and this is our first time we've seen a number all on its own without being in front of a letter. So a number on its own is called a constant. It's a little different than coefficient. So here we have another example of, in black, the polynomial is 2x cubed plus x. So the coefficient is 2, and there's also a coefficient in front of the x. It's just not drawn in. The coefficient of 1 is not shown. The variable is x, and the exponent is 3. So name the variables, coefficients, exponents, and constants. So the variable is x. I like to write them algebra style. Coefficient is negative 5, and there's a 1 here, right? So negative 5 and 1. The exponent, there is a 2. There's also a 1 here, right? So 2 and 1. And the constant is the number all on its own, negative 6. Okay. Here we have a variable is the y and the x. Coefficients, we have 9, negative 3. Exponents, we have a 5. We also have the 1 here, so we have 5 and 1. The constant is the number all on its own, positive 8. And I think the last example here, we've got a variable of m and n. The coefficient, there's a 1 here, right? So we have 2. We have a negative 1 and a positive 2. So just 1 and 2. The exponents, we have a 4 and a 7. And a constant is the number all on its own, that's 12. Positive 12 or just 12. So every polynomial has a degree. To find it, look at each term and combine the exponents that are attached to the variables. The highest answer is the degree of the polynomial. Okay, you might have to pause that and kind of reread it, but here's how it goes. So here's the example. We have 9x cubed minus 4x to the power of 5, positive 3. So this, you look at the exponent attached to the variable. So that's a 3 attached to the x. So it has the exponent has a degree of 3. This has a degree of 5 because the exponent has a 5. Constants never have degrees, so it has a degree of 0. The highest of the 3 is the degree of the entire polynomial. So this polynomial has a degree of 5 because 5 is the highest. If we have this polynomial, 8x squared y3 minus 6xy plus 3x minus 5. So you look at each term. So these exponents are attached to these variables. You always look at the variables. So 2 and 3, combine those, has a degree of 5. This part, negative 6xy, has two 1s as exponents, so degree of 2. This x has a 1, so exponent degree of 1. This is a constant, never has a degree, so the highest is 5. This polynomial has a degree of 5. So explaining why this polynomial has a degree of 7. So we look at this part here. So we have a 2 and a 5. That has a degree of 7. This part here has a 3, there's a 1, and a 3, which is a degree of 7. They're tied. This part has a 1, a 3, and a 1 for a degree of 6. This part has a 0 degree. So the highest degree that was reached was 7, so this polynomial has a degree of 7. Even if there's a tie, that's what we look at. So last examples here. So name the degree of each polynomial. So this one has 1, this one has a 1 and a 3, so that's a 4. This one has a 4 and a 5, which is 9, so this has a degree of 9. The entire polynomial, that's the highest. So this exponent has a 2 and this one a 6, so that's a degree of 8. This one has a 1 and a 5 for a 6. This one has a 1. This one has a 0, so this one has a degree of 8. Finally, this is a 2. The e has a 1 and a 6, so that's 9 there. This one has a 1, a 2, and a 1 for a degree of 4. And this one has a 5, a 3, and a 4 for 12. So this one has the highest degree reached was 12. And I believe that is all that I have for you. If you go to my website and watch this video, I hope it sure helped you. And good luck in your polynomial unit. Have a good day.